Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.1 day 2. We're going to be performing a variety of operations using polynomials. Okay, so polynomials refers to any kind of like expression that's set up this way. All of my exponents are positive exponents. There's no division or anything like that. They're all just x cubed, x squared, x to the first, things like that. So when we add or subtract, we're just going to combine like terms, and that's what we're going to look at here. Since this is addition, we can just simply take 2x cubed and x cubed, add those together. So that becomes a 3x cubed. And here we have negative 5x squared and a positive 6x squared. So negative 5 plus 6 gives me a positive 1x squared. And then I'll do circle 3x, and there's no other x's there. So that actually is done. So I'm just going to bring the 3x and add it to there. And then finally, let's do a triangle, negative 9 and positive 11. So negative 9 and positive 11 go together to make it a positive 2. But the next one, we have to make sure that we are going to take care of the negative sign here first. If I am subtracting this polynomial, I am subtracting every single term there, meaning it's a kind of like distributing the negative sign. So 4z, oops, bring that back, 4z squared plus 9z minus 12 minus 5z squared plus z minus 3. So now I can go back and look at what can I combine. So I can put together my z squareds. 4 minus 5 is going to give me a negative 1z squared. 9z and positive z here is going to come together as a 10z. And then negative 12 and negative 3 come together as a negative 15. On the next one, same idea, but I need to first distribute the negative 2 to everything. So it'll be 6x squared minus 10x plus 5 minus 6x squared. Negative 2 times negative 4 is a positive 8x, and then negative 2 times negative 1 is a positive 2. Again, look for those like terms. We got 6x squared and negative 6x squared, so those just cancel each other out. They're gone. We've got negative 10x and a positive 8x is a negative 2x. And then we have positive 5 and a positive 2 gives me a positive 7. So there's my final answer there. Okay. We can multiply with our polynomials. Now, you've seen distribution in the past. You can do this any way you want. For example, some people like to just take the y and distribute to everything. Negative 2 distribute to everything. That's totally fine. I like to organize this a little bit differently. Since I have 2 terms and 3 terms multiplied together, I'm going to make this into a 2 by 3 box. So I like to multiply through. I have y minus 2 here. I have negative 2y squared plus 3y at a minus 6. Every box is going to be the multiplier of what's above and to the left. So if I do this, I've got negative 2y squared, and y is a negative 2 times y to the third power. 3y and y is going to make 3y squared. Negative 6 and y is negative 6y. Then I come down here. So negative 2y squared times a negative 2, positive 4y squared. 3y times a negative 2 is a negative 6y. Negative 6 times negative 2 is a positive 12. Now, I just need to find my like terms. In the box method like this, they're really organized. Most times they're going to be like on this diagonal, like these two and like these two. They won't always be that way, but it's nice when they do. So now I can write out negative 2y cubed. 4 plus 3 is going to give me a 7y squared. Negative 6 and negative 6 is a negative 12y, and then positive 12. When I do this one right here with the 2 or 3 sets of binomials, I first need to do one set of binomials. Okay, so for example, let me start with x plus 1 and x plus 3. Doesn't really matter, but you can do whichever one you want. I'm going to go ahead and stick with the box method. So this is 2 and 2. I'm going to do x1 and x and 3. X and x is x squared. 1 times x is x. X times 3 is 3x. Well, hello, come back here. Okay, and then 1 times 3 is 3. Here's my like terms. So now this is going to turn into x minus 5 times x squared plus 4x plus 3. So then I'll do again where I do a 2 by 3 box. So x and a negative 5, got x squared, 4x, and 3. So I've got x times x squared is x to the third power, 4x squared, 3x, negative 5x squared, negative 20x, negative 15. And again, you're going to look for where do they match up with their like terms. So in the end, I'm going to have x cubed. Negative 5 plus 4 is a negative 1x squared. Negative 20 plus 3 is a negative 17x. And then a negative 15. Okay, so we've done adding, we've done subtracting. Let's do another multiplying with this. Always remember, we multiply this. This is representing 2x plus 3 times 2x plus 3, meaning we have to distribute. And again, I'm going to go ahead and do the box method. So I got 2x plus 3, 2x plus 3. So 2x and 2x is 4x squared. 3 times 2x is 6x. Same thing here. 3 times 3 is 9. So this turns into 4x squared plus 12x plus 9. Write the figure's volume as a polynomial in standard form here. Since this is x minus 5 and it's all congruent here, so that's going to be x minus 5 and x minus 5. So what that means is my volume is going to be x minus 5 to the third power. So it's going to be very similar to this problem, but now I have to do x minus 5 in all cases. So I'll start with this one. Do x and negative 5, x and negative 5. So it's x squared, negative 5x, negative 5x, and a positive 25. So that's going to become x minus 5 times x squared minus 10x plus 25. Again, I'm adding these together to get negative 10x. Then I'm going to do a 2 by 3 box. So x negative 5, oops. And then x squared, negative 10x, and a positive 25. So I multiply here, I got x cubed, negative 10x squared, 25x, negative 5x squared, positive 50x, and a negative 125. So my volume comes out when I do this all. I've got, color coded a little bit here. Got those coming together. So it's going to be x cubed, negative 15x squared, positive 75x, and then a negative 125. Okay, so one other thing we want to talk about here, and that's going to be dividing with polynomials. So that's our last operation. We've done adding, subtracting, and multiplying. Now let's do division. We're going to just focus on what's called synthetic division. It has a very specific way to write it out. If I'm dividing by this factor, x minus 2, what I'm going to do is I'm going to take all of my coefficients, like 1, 5, negative 7, and 2. I'm going to line them up right here. So 1, 5, negative 7, and 2. I'm going to draw a line somewhere below. I'm going to take x minus 2, but I'm going to take the opposite of the negative 2 and make it a positive 2 and goes right here. Now I'm going to put a little box on the side. Here's the steps that it takes. If I take 1 and drop it down, this number is going to multiply everything that's in this row. Once I multiply by that, that comes up here. So 2 times 1 gives me 2. I'll write a 2 right here. Everything that's in the columns here, they're just going to be adding or subtracting together. So that means 5 plus 2 is going to give me 7. 2 times 7 now is going to give me 14. So that's going to go right here. Negative 7 plus 14 is going to give me a 7. Finally, 2 times 7 is going to give me 14 again. 2 plus 14 is going to give me 16. This number here is always the remainder. So when I do my polynomial division like this, here's what I get. Since I started at x cubed, x squared, x to the first, and then no x, then down here at this level is x squared, x to the first, x to the, well, technically x to the 0. There's no x there, we can call it x to the 0. And then this is my remainder. So the result of this is going to be 1x squared plus 7x plus 7 plus 16. And I like to write my remainders as 16 over our original divisor, which in this case is x minus 2. So that's my final answer for that one. So synthetic division might seem a little bit tricky, but it's just the same steps every time. So let's look at this one right here. Now notice when you write this out, well, this one was already in order. It went from x cubed, x squared, x first, and then there was no x. This one's not in order. So we want to make sure we do our terms in descending order, and then also make notes of anything that's missing. Okay, so for example, let me rewrite this a little bit. I'm going to do x to the fourth plus 4x cubed. There is no x squared value, so I'm going to call it 0x squared for now. And then instead of writing the 35, I'll go with a 16x because that's 16x to the first. And then minus 35. Okay, so that is being divided by x plus 5. So I'm going to set it up now with my new coefficients. That's 1, 4, 0, 16, negative 35. 1, 4, 0, 16, negative 35. I'll put the opposite of the positive 5, so it's a negative 5. And now I run through that program. So I drop the 1 down. Negative 5 is multiplied by 1, so that's going to give me a negative 5. 4 minus 5 is a negative 1. So negative 5 times negative 1 is a positive 5. Combine that with the 0, I get 5. Negative 5 times 5 is a negative 25. So this will give me a negative 9. And then negative 5 times negative 9 is a positive 45, which gives me 10 for my remainder. So that means my polynomial that results from this is going to be, since I started with x to the 4th, I'm just going to drop down 1 degree. So it's going to be 1x cubed minus 1x squared plus 5x minus 9 plus 10 over x plus 5. Okay, and that is it for today. These are all the operations we did. So again, if we start with addition like this, we're just combining like terms. Subtraction, make sure you're subtracting everything, but still combining like terms. When we multiply, we are going to do distribution. I like doing this box method for distribution, but once you do that, you're also going to combine like terms. And finally, we did division. No combining like terms here in this case, but here's our process. Here's our synthetic division. You line up your coefficients, your divisor goes here where it's the opposite of what number is there, and then you go through this process like that. Okay, that's it for today. Take care, everyone.